All right, let's dive right in. Today, we're taking a journey deep inside a part of the brain you've probably heard of by its nickname, the little brain. But as we're about to discover, there's absolutely nothing little about its power or its impact on who we are. Okay, just to kick things off, get a load of this statistic. The cerebellum, the structure we're talking about, takes up only about 10% of your brain's total space. But, and this is wild, it's packed with over half of your brain's total neurons. Just let that sink in for a second. More than 50% of the raw processing power of your entire brain is crammed into this one super dense region. Right away, that's a massive clue that its job is way bigger than we ever give it credit for.
For the longest time, we've thought of the cerebellum as the movement and balance part of the brain. And yeah, it does that. But that's not even the whole story. So the big question we're tackling here is this. What are the hidden challenges? What really happens when something like a tumor starts growing in this tiny, yet incredibly powerful region? The answers you'll see are pretty shocking.
Okay, let's get into it. To really get a handle on the unexpected stuff, we've got to cover the basics first. So think of this first part as your quick start guide to what the cerebellum is famous for, being the brain's master motor control center.
So, what's the cerebellum's day job? Well, it's constantly working behind the scenes, making all those tiny adjustments that keep you standing upright without you ever having to think about it. It's the master coordinator, making sure all your muscles work together when you decide to, walk or reach for something. And it's also how we learn new skills. It fine-tunes everything through trial and error. Think about a pitcher learning to throw a perfect curveball. That's all cerebellum.
Now, here's a really important rule about the brain's wiring that can get a little confusing. Your main brain, the big cerebral cortex, has this crossed wire system. The left hemisphere controls the right side of your body, and the right hemisphere controls the left. That's called contralateral control. But the cerebellum, it does things differently. For movement, it controls the same side of the body. We call that ipsilateral control.
And that makes this part seem pretty straightforward. If you have a tumor on the left side of your cerebellum, you're going to have motor problems, like shakiness or coordination issues on the left side of your body. It's a direct, same-side connection. Simple enough, right? Well, this is exactly where the story takes a sharp and fascinating turn. So let's move on, because we're about to see how this gets complicated. We're now entering a tale of two hemispheres, because when we stop talking about movement and start talking about thinking, language, planning, even our emotions, the cerebellum flips the script and plays by a totally different set of rules. This quote from a major NIH study is basically the big reveal. Let me translate it from science speak. It's saying that if you damage one side of the cerebellum, you get cognitive problems that you'd normally expect to see from damage to the opposite side of the main brain. So for thinking, that simple same-sided rule we just learned, yeah, you can just throw that right out the window. The wiring crosses over.
So what does this actually mean for someone? Let's break it down. If a tumor grows on the left side of the cerebellum, the cognitive issues tend to be pretty specific. Studies show these patients mainly have trouble with visual spatial tasks. We're talking about things like reading a map, judging distances, or picturing an object rotating in your mind. They also show problems with attention.
But here is the real stunner. If that same lesion is on the right side of the cerebellum, the impact isn't so selective. It can be a much bigger, more widespread cognitive decline. Suddenly, you're seeing significant problems with language, memory, attention, and visuospatial skills all at once. It's this incredible asymmetry that can have truly life-changing consequences.
And that brings us to the unseen challenges. Because for patients and their families, these symptoms can be so confusing. They're expecting problems with walking and balance, and instead they're facing something entirely different.
Scientists now have a name for this whole collection of issues: cerebellar cognitive affective syndrome, or CCAS for short. And it's not just one thing. It's this complex mix of problems with what we call executive functions, like planning your day or staying organized, along with trouble with language, visual spatial skills, and even regulating emotions, which can lead to really noticeable personality changes.
Now, you don't have to take my word for it. Let's look at the data, because it is stark. This chart shows the results of a simple test where people had to name 12 common objects. The healthy control group, they nailed it. Perfect score. Patients with lesions on the left side, also a perfect score. No problem. But look at the patients with lesions on the right side. Their average score plummets to 8.5. That isn't just a little slip-up. That's a serious, measurable difficulty with something as basic as finding the right word.
And the most important thing is what this looks like in the real world. This isn't just about a score on a test. It's struggling to find an everyday word, a condition called dysnomia.
It's having trouble just planning out the steps to make breakfast. There's even a physical sign called dysdiadochokinesia, where a person can't do simple, rapid movements, like tapping their fingers. And maybe the hardest part for families, it can show up as major personality shifts, like emotions becoming really flat, or a person suddenly becoming very impulsive. These are the truly unseen challenges.
So the big question is, why? How is it possible for this small structure at the back of our heads to have such a huge influence over everything from how we walk to how we talk and even how we feel? Well, the answer is that the cerebellum is one of the brain's great communicators. Here's the secret. The cerebellum is not a solo act, not at all. It's locked in this constant, super high-speed conversation with the cerebral cortex, the part of the brain that does all our complex, higher-level thinking. That connection, that feedback loop, is the source of its immense power.
Let's walk through how this loop actually works. Think of it this way. First, the cerebral cortex, the CEO, sends down a rough draft of a plan. It could be a physical plan, like let's walk, or a mental one, like let's form a sentence. Second, that plan goes to the cerebellum. Third, the cerebellum acts like the world's best editor. It checks the plan for errors, smooths out the rough edges, and makes sure everything is coordinated perfectly. Finally, it sends that polished, perfected plan back up to the cortex to be executed. This is happening for almost everything you think and do all day long.
And if you need one last piece of evidence to seal the deal on how important this is for thinking, here it is. Modern brain imaging shows that around 70% of this communication between the main brain and the little brain involves cognitive areas, not just motor areas. So the vast majority of that constant chatter is about thought, language, and emotion. When you put it all together, it's clear the cerebellum is no little brain. It's a fundamental architect of our reality, shaping not just our movements, but our thoughts and feelings too. And that leaves us with one last big question to chew on. If we've been this wrong about something so important for so long, what other incredible secrets is our brain still hiding, just waiting for us to find them?